Okay, so this is the topic about valence bond theory.
Valence bond theory, or commonly it is also known as VBT, explain the bond energy, bond length, orbital overlapping, and shapes of the molecules in a covalent bond. It only teaches us about the covalent bond, not about ionic bond. VBT was first introduced by Hitler and London in 1927, and later on it was developed by Pauling and others. There are the following postulates of VBT we are going to discuss. First is covalent bond. How covalent bond is formed? Formed by the overlapping of two atomic orbitals. Here you can see I have taken an example of HCl, H which having the 1s2, 1s orbital, and chlorine, that is 2p. They are they combine together, and this is the overlapping reason. Okay. Next. Next is your types of orbital. Only half-filled orbitals overlap. Here you can see this is the example of full filled. One s is full filled and two is half filled. So these types of orbitals cannot take in participation of overlapping. In overlapping, we must need a half filled orbitals. Third one is spin of electrons. Spinning of electrons. Spinning of electrons means orientation of the electrons. So spinning of electrons must be in opposite direction. Both the electrons are must in opposite direction, then they will take a formation. They will take a part in a overlapping and will form the covalent bond. Identity of the orbitals. Orbitals retain their identity after overlapping. Let's consider we are taking an example of 1s of H and 2p of chlorine. That H is a spherical, S orbital in a spherical shape, and p orbital is a dumbbell shape. So after reacting, they will retain in their shape. H will also stay in a retain in a spherical shape, and p orbital is also in a dumbbell shape. You must remember energy of atomic orbitals are always higher than the overlapping orbitals. Now the fifth point is number of bonds. If there is one unpaired electrons present, then one bond will be formed. If there is a two unpaired electron will present, then two bonds will be formed. If there is a three unpaired electrons, then three bonds will be formed, and so on. So here I've taken the example of nitrogen, which has got three unpaired. How many unpaired electrons? Three unpaired electrons. So it will form three covalent bonds by participating overlapping with the unpaired electron of hydrogen. Now the triple one. Now the sixth point is bond energy and length. The extent of overlapping decides the bond energy, bond strength, and bond length. So here, if your overlapping is higher, your bond strength and bond energy both will be higher, but bond length will be smaller, and the vice versa. Here I have taken an example of pi bond. Here it is a lateral overlapping, or we can say it's a parallel overlapping, lateral overlapping. If overlapping is minimum, the bond energy and bond strength will be smaller, but the bond length will be higher. Here, I've taken example of s orbital. Head-on overlapping, maximum overlapping. If your overlapping is maximum, your bond energy and bond strength will be higher, but the bond length will be lower. So we can say overlapping is directly proportional to the bond energy and the bond strength, but it's inversely proportional to the bond length. Now, sigma and pi bond. How sigma and pi bonds are formed? Two types of overlapping, axial and head-on, always form sigma bond. Axial and head-on overlapping always form sigma bond. Here you can see how sigma bond is formed. And parallel and side-to-side overlapping always forms pi bond. This is a parallel and side-to-side overlapping. This is formed what? Pi bond. This is um, much weaker than the sigma bond. Sigma bond is much stronger than the pi bond. So this is for it today. Thank you so much for listening till the end. Bye bye. Thank you.